Now, question 1, a coulomb per second is just the definition of 1 ampere. So that is C. And number 2, again, it's definition, current's the flow of positive charge. So 3, the thing that's true is that the current is the same everywhere. And so that is A. And 4, we have current density equals number of charges per unit volume times the charge times their drift velocity. Now, remembering that current density equals current per unit area is N times E times V, and they say that it is a unit area, so we're counting that as 1. So we can say that 2.5 equals the number per volume times the charge, 1.6 by 10 to the minus 19, times the drift speed, which is 0.1 millimeters per second, which is 0.1 by 10 to the minus 3 meters per second. So we end up with N equals 1.6 by 10 to the 23, and that was D. Now, question 5. We'll start with a length that has cross-sectional area A, length L. Now, we have it being pulled out until it is 3 times the length, but the volume is going to stay the same, and the volume is the cross-sectional area times the length. So the new volume will be 3 times the length, but it has to equal the old volume, so it has to be 1/3 of the cross-sectional area. So let's have a look at the resistance then. Rho stays constant, it's times L times A. So the new resistance, it's the same resistivity. We've got 3 times L. We're dividing it by A over 3, so it's actually 9 times the old resistance, which is 9 times 6, which is 54 ohms. Now, number 6, we have a current density of 440 amps per square centimetre, and we want to know what could be the radius of a wire that could safely carry 0.5 amps. So we have current density is just current per unit area. So we have the area is actually area times J is current, so area equals I over J, which is the current we can take over the maximum. So we end up with an area of 1.14 by 10 to the minus 3 square centimetres, and that equals pi r squared, because it's circular cross-section. So r squared is going to be 1.14 by 10 to the minus 3 over pi, 3.62 by 10 to the minus 4. So we end up with r equals 0.019 centimetres or 0.19 millimetres. Now, number 7. The first thing we're doing, now we have a current density of 8.7 per cubic centimetre. Now, if that's in 1 cubic centimetre, we want to turn it into cubic metres, so that will be 8.7 by 10 to the 6, because it's 100 centimetres in a metre, so 100 times 100 times 100. So that bigger number per cubic metre. And we have the drift velocity is 470 kilometres per second So 470 by 10 cubed meters per second. Now the current density is the number times the charge times the drift speed. So we have 8.7 by 10 to the 6 per cubic metre. The charge is 1.6 by 10 to the minus 19. And the speed, 470 by 10 cubed metres per second. And that gives us 6.54 by 10 to the minus 7 amps per square metre. And for part B, now the current is just the current density times the area, and the area here is the Earth. So we have the radius of the Earth, which is 6.38 by 10 to the 6 metres. So the area equals pi RE squared. So we have the current will be the current density. Now that was 6.54 by 10 to the minus 7, but we're now timesing it by pi times 6.38 by 10 to the 6 squared. We end up with a current over the whole Earth of 8.36 by 10 to the 7 amps. Now for number 8, we have a wire. Its length is 1. The cross-sectional area is 1 square millimetre, which is 1 by 10 to the minus 3 metres squared, which is 1 by 10 to the minus 6 square metres. Now the resistance we just get from the voltage over the current. So 2 volts gives 4 amps, so that is 0.5 ohms. And the other thing we know is that the resistance is rho times L over A. So that means rho, if we make that the subject, we times both sides by A, divide both sides by L. So now resistance is 0.5, area is 1 by 10 to the minus 6. And we have then a resistivity of 5 by 10 to the minus 7 ohm meters. Now that was part A. And part B is that you can define a quantity called the conductivity, which is sigma, which is just the inverse of rho. So that is simply 2 by 10 to the 6, and the units have to be the inverse of the resistivity units, so that is per ohm meter.